Hey, how you doing? My name is Wesley Knauf, and I'm here today to give you an informative speech about gears and how to be a machinist. Well, as you can guess probably by now, that's what I do. I'm a machinist. I make parts from steel and turn them into something that looks a little like this. This is just one example of a part. We'll get into a little bit more detail on that in a second. I work in a place called Great Lakes Industries. Uh, this place is a great place to work. I came into the industry not knowing a thing about it, not even knowing what a sprocket from a gear was. Um, I didn't know anything. They took me under their wing and taught me everything I needed to know. Be an independent worker, to be my own person, and to be my own operator, basically. So when I first got at Great Lakes Industries, they explained to me their policy. And the policy is to deliver defect-free parts on time that meet or exceed the expectation of our valued customers. I took this as kind of my own interpretation of it as being on time, yourself as an employee, always doing your best to deliver parts that you know are good, and always try to satisfy the customer because that's our main goal, to make the customer happy and we'll be happy. And then we'll all be happy. Anyways, well, when I first got there, it wasn't like a lot of other shops you hear about. It wasn't dirty, wasn't nasty. It was nice and clean. You walk in and people are kind of saying hi to you, how you doing, and they stressed to me at first, we want you to learn how to be safe. That's our main goal for here first, because we can replace tooling, we can replace gauges, we can replace machines, but we can't replace you. And this really, really hit me hard, saying, they really care about their employees. So a few things that I've learned in the few years I worked there was how to be safe. First of all, you always need these pair of safety glasses. Um, Debris can fly up, hit you in the eyes, but with these, stops, and you can see, and we all like to see. So these safety glasses have saved my eyes a bunch of times, and one thing that we always need to do is wear these if we're out on the floor in the shop. Another great thing that we always have to use are earplugs. Now, there are certain different types of earplugs, and all of them are a little different, but they all do the same thing: protect your hearing. We all take annual hearing tests there, and we all need to be evaluated once a year, and you should always wear these. There's no excuse not to. You won't be able to hear if you don't. Another great thing that we have are these things: gloves. Now, some of the parts create debris and burrs and chips. So these gloves help you protect your hands from injuring themselves, and you don't want to put your hand in coolant all day or in oil all day. It'll tear on your hands, and you need these to work. So these are a great part of protection, safety. Now, safety was a huge thing when I got there. I mean, it still is, but they made me stress the feeling that I need to be safe no matter what I'm doing, and that was great. I loved it, loved every second of it. The next thing that I went through was quality. Now, at a place like a shop, the quality of a part is almost more important than safety, but you're irreplaceable, so safety is top. But quality is next on the line. Because if you don't have quality parts and you just are running all day, running parts all day, not even checking them, you could have a run 200 parts and only one of them could be good. Now the guy who ran 4 parts and you ran the 200, his 4 parts are good and you only have one good one. Which one do you want? You want good quality parts. And once you get these things down pat, the next step will come, which is production. We'll talk about that in a minute. But quality comes through. Let me use this for example. This is a part that we made here at Great Lakes Industries. Now, this part is actually a scrap part because the quality is no good. I don't know if you can see, but the teeth are chipped up here. That might not be the only thing that's wrong with it, but you can visually see that. What we would do is we'd run this part and we'd look at it. And we use a thing I got in my hand right here called calipers. Now, if you get a little closer look of that, these calipers are in inches. Inches, thousandths, hundred thousandths, tenths. Now, see this part is about 560, we'll say 66 thou. Now you're probably thinking, I have no idea what that means. Well, let me put it to you this way. This whole thing right here is a foot, 12 inches, 6 inches right here. Now, if you take a piece of hair and measure it, you're getting about 2 thou, 2.5 thou. So one piece of hair is about 2.5 thou. We go up to thousandths. Tenths. And that would be 20 times smaller than a piece of hair. So we can precision gears or sprockets just like this up to that tolerance or more. So this is how good of quality control that we have at Great Lakes Industries. Or better. We're always trying to get better than that. We have machines that can go greater than that with quality. But we have things like this to check our parts. Now this is called a calipers. And these parts, these are all certified by our shop. They're all put in the system under a code that we have right here, and they're all signed off. See, this gear number is 1934, and it was signed off this month, and it's good for a year. And they get checked with these things called gauge blocks. And they're basically little blocks that we use that are certified by the state gear manufacturing company that we can use to make sure all our parts are good and all our calipers and all our gauges are good. Now we have a bunch of different things to check. This is just one of the basic ones that we all have to buy. Unfortunately, I wasn't able to take any home to show you, but I can give you a good demonstration about what we use things like this for. Now we also have another one that's just set basically for the bores. The bore is the middle of the part that is the circle basically right here. And we call this a bore, and the bore usually fits over something, goes on something, and then turns like this. Now this part I have right here is a sprocket. And sprockets are on both, basically anything that you see or use throughout the day. A big thing that I like to compare sprockets to is your bicycle. Now, your bicycle has a sprocket on it that pulls the chain. And once in a while, your chain will pop off and you have to put it back on. Now these pins, this radius right here, is where the pins will sit. And it will pull your chain of your bicycle. So these are one things that we make here at Great Lakes Industries, are sprockets. And we hold them to quality control through our gauges and gauge blocks. Another thing that we do is we make gears. Gears are a lot like sprockets, but they're totally different. You really know what you're talking about. Let me draw you a picture here. Now, main thing about sprockets and gears are that gears indicate themselves and use most of the pressure on the root. Sprockets too, Sprockets on the root. Now, the sprocket sits on there as a chain pulls. So, the chain's pulling like this, where a gear has more of a tooth-to-tooth action. So that part right there is getting up to another part on the teeth right there. So one gear's going this way, the other one's pushing this way. So the teeth are going off each other. Unlike the sprocket, where the pin actually sits in there and gets pulled by the pin. It gets pulled by the gear itself. It sits in the root. It's not pulled like the gear is from tooth to tooth. Sorry, tooth to tooth right there. Now, the reason why we have to create different things from a sprocket, from a gear, is because sprockets themselves are a lot weaker than gears. They don't have enough pull that we need to power things that gears can do. See, this is fine for when we're riding a bicycle or making little motors go or something like that, little chains pulling it. But when we have to have stuff like drive shafts and things in our big John Deere tractors, or things in our oil rigs, oil boxes that need to pull and push a lot of torque, a lot of horsepower, that's not strong enough. They'll break. We have to go with something like a gear. Talking about gears and sprockets leads me to the next section, which would be what we actually do at Great Lakes Industry and what we make. We make a lot of different things. Some cool things I've learned that we made are, one, we make a gear that fits into a machine bike, exercise machine bike. So it goes back and forth, and our gear's in there turning to make tension going however much you want it. Another thing that we make is a spur gear, which is kind of, keep in mind this is a sprocket, but pretend it's a gear. It's kind of a cut in half gear that kind of goes just like this, back and forth. And this gear helps create hamburgers. Kind of goes back to where I used to work and before this. But that's a different story for a different day. But yeah, we make other things also, like portable gearboxes, where these big oil rigs who go and find oil in certain spots and won't be there very long, say small amounts, will go and set up, and we make these gears, these huge, massive gears, to pull all this oil up and out. And they're really, really crazy. We can reverse engineer to make them all fit in the box, and we can take them all out and see dimensions and everything like that. Well, I told you a little bit about the gears, a little bit about the sprockets. Let me tell you how we make them. How I make them, I should say. We have this one thing called a cell, and that's where I live my life. We have a program called Life in the Cell, and it's supposed to make the operators feel like they are in their area and they know where everything is laid out, so it can have a smooth rotation throughout the whole cell. So, for the sake of the argument right now, I'll go through a little bit, draw you a little picture so you get a good estimate of what things are. First of all, let's talk about a lathe. Let's say this is a lathe right here, and this board is our cell. A lathe is a machine that takes the stock, and a stock is just a piece of metal. It would be a piece of metal that is blank, has nothing in it, no holes usually, and just faced off, just a whole chunk of steel. What we like to do, or what we do, is we take this steel, put in some chucks, and the chucks are like hands that hold the part. And once we put it in here, our engineers make programs to come in and face the part off. So we cut off the material from the gear or sprocket, or whatever we're making, and we do exactly what the program says. So we get the print from our customers, and then we say, okay, this is what we have to program it for. So we program it per that print, per what the customer says, and make a part. Once it does one side, we flip it around, clamp it up, and we do the other side. And this is the side that we usually do the bore on. And the bore is very important. This part of the part right here is called the bore. The bore is what it usually indicates on. And we need the bore to be straight as possible for when the part turns, you don't want it wobbling. Because if it wobbles and you're riding your bicycle, your chain could pop off. We don't want that. I mean, not all the parts are for bicycles, but that's a great, example. We'll stick with it for a while. So you have a part, and it has no teeth in it. It's just a normal piece of steel that looks like this. That circle with a hole in it. And that's all you got. Well, the next part that we go to is called, the machine I should say, it's called a hob. And the hob, right here, we'll say, the hob puts the teeth in the part. So the part sits on an arbor, so to speak, and it sits and gets the teeth put into it. Now the teeth get put into by something called the hob cutter. The hob cutter is a very strong piece of metal that is basically precisioned as a big cutting tool. So it's basically like a huge lawnmower that's cutting the grass, but we're cutting the gear in very, very good measurement, precise measurement. So this hob comes in, spins. While this spins and cuts it, it rotates, and it goes deeper and deeper until we get the right size. And then after we get the right size, we pull the part off. We use the air hose to spray it off all the oil, and then we go to a machine called the deburr center. And usually that's pretty close to the hob. So we'll just put DB for deburr. So we deburr the part, which means to take the metal excess off the part to make it smooth. Because we don't want it to get cut. We don't want anything bad to happen to the part. We want it to be smooth. We can touch it all. We want it to be in working condition. Once we do that, we next usually take it to either a VMC to get holes drilled into it. VMC, which is usually either pretty close to the deburr station with the lathe, or sometimes both. We take it to a broach. Now, you can kind of see here how the cell looks like it's a rotation. You go from one to the other to the other. Kind of make a nice flowing situation out of the whole thing to make it a nice flow. Let me tell you a little bit about the broach. The broach is a long machine that has a broach bar, and the broach bar sticks in the bore. Now this part doesn't have it, but let me draw something here real quick on the part. The broach will actually take material off the part of the center of the bore. Now this would be a spline. Let's say it takes off all that material and you're left with nothing in the middle. You're just left with all these teeth around you. And that's another way that they can indicate it on an arbor or a gear to make it pull faster or whatnot. And that's what the broach does. It takes material out of the center. The VMC that I talked about earlier does the holes, drilling the holes, or drilling the drilling the holes or drilling the screw, places for screw, which you call taps. So we tap the part so we can put a screw in it. So we can have this part possibly bolted down to somewhere else while it turns, so it doesn't move anywhere. Or maybe a set screw so the thing inside of it doesn't move if we don't have a broach set in place. But yeah, that's kind of the life in the cell. And we do this every day. We go from one operation to the next, and the next, and next to make production and to make parts. We then put it down to shipping, and then our shippers pack it up in a nice location, make it all so they don't move, bounce around each other, and we send it out to our customer. Or we send it to go get heat treated and make the steel harden, or whatever the next operation is. But that's what really we do as machinists, our section of the job. A few things that I've learned and appreciated from this place are the experiences that I've learned dealing with other people who are maybe older than me, younger than me, problem solving. I love the fact that I've obtained so much knowledge in problem solving. One thing goes wrong, next thing goes wrong, and what are you going to do? Well, you're going to try to figure it out. You're not just going to go say, well, I can't do this anymore. You're going to try, and you're going to figure it out. Another thing that I've learned to do here is keep things clean, because if things aren't clean, things could go wrong. This job has helped me a lot, and I hope this video helped you a little bit on learning what a machinist actually does and what the parts actually do and how I make them. So thank you for your time, and maybe I'll see you in the shop one day. See you later.